Algebra 2 friends, welcome to a little installment of this intro to logarithmic functions. Now, we aren't going to use the word logarithms right now because we're just wading into it. So this video is meant to kind of cover what just happened on what we call cycle 33, the first day of the unit. So this is the packet, and if you don't have the packet yet, no worries, but I'm going to take you through kind of something just to watch and see, like, okay, I see where we're going with that. This is in the functions unit, sorry, in the logs unit. Many of the pages are numbered in log form, and so here's just a really quick way to evaluate the log of 81 base 3. That's how I say it. The log of 81 base 3. The long and the short of it is, this is a problem, and it's to evaluate, you find out, like, the question is really asking what power was 3 raised to get 81? You could guess and check, but it's also, there's a way to put it into your calculator, but how many times does 3 need to be raised to get 81? You could go, okay, 3 times 3, that's 2, that's 9, times another 3, that's 27, times another 3, 81. Oh, answer is 4. The answer to this problem is 4. So many of the, that's kind of how those work out. And so many of the problems we put in there are ones that should be like almost mental mathy type ones on how to do that one. So the page we're going to hover on here is this log of 32 base 2. That means what power does 2 need to be raised by to get 32? This is page 5. All right, so let's clean this up a little bit because we're going to be working down here, and we're going to be working on page 5, and then the next one there, which is 3 times 2, page 6, page 5 and 6. So the objective for this one is to introduce inverse functions, how to test to see if a function is an inverse of another, and then how to find it. This is going to go pretty fast, so slow me down or slow down the video, or like pause it. This is just meant to give you some quick notes. Inverse functions are functions that undo each other. And if you compose one function into another, and when you do, x is the output, those functions are inverses. So if f and g are inverses, then this happens. G of f of x or f of g of x churn out x. What's really disappointing and very sad is that we just finished with an exponential unit where this -1, which looks like an exponent, is meant to be like to put that function in the denominator. It becomes positive. That's not what this is anymore. This f, which looks like f -1, is called f inverse. It has nothing to do with exponents in this case. I know, I'm so sorry, but notation has been started and finished over the years, so it's not as if everybody started out with one thing and made it clear. Here's something that I think might help when it comes to inverses. There's always these two sets. One is usually the domain of f. If f takes something into another, it maps it to another place, and that domain of f is set over to the range of f, inputs and outputs. Now, but if there's going to be a function that takes them back, called the inverse, f inverse of x, then what used to be the range of f is now the domain of the inverse. And then if the inverse takes it back to this original oval here, then that is now the range of f inverse. So these sets become either domains or ranges depending on which direction you go. So these four spaces here are meant to be the range of f of x now becomes the domain of f inverse, and the domain of f of x becomes the range of f inverse. Is that right? Wait a second. Yes. Okay, so there's a big caution sign, like this -1 does not mean it's an exponent. It really means that's the notation for the inverse. So here's a quick way to kind of think about and think through the domains and ranges of these inverses. This is a function that takes four numbers, 1, 2, 3, and 4, those inputs, into four different outputs, 5, 10, 15, and 20. So it looks like the f function is like a quadrupling factor. So I'm just going to make a little note of that. Looks like f of x quintuples 5 times. It is the quintupling machine. So the domain of f, in this case when we write just discrete numbers, they can have these curly Q brackets, and it's not set, it's a different type of set notation, it's not an interval, so we could just write 1, 2, 3, and 4 are the numbers in this domain of f, and then they are sent over to the range of f, which is 5, 10, 15, and 20. The inverse of f, we could probably, like, this one is easy enough that if you have a function that multiplies everything by 5, its inverse, if we were to characterize it by an equation, would be something that takes everything divided by 5, or 1/5 times that number. So the domain of the inverse now is those numbers 5, 10, 15, and 20. We're going in the reverse order, and they're mapped to the range of f inverse, the outputs, which are going to be 1, 2, 3, and 4. So it's a good way to think about functions. You could look at them as a table, or here's an ordered pair. It's also put in terms of a picture, which sometimes helps to think of the different functions of f of x and then f inverse of x. Okay, two big skills now are going to be how to determine if two functions are inverses of another. Here's what you do. In order to test, you take f of g of x or g of f of x, and if one is put into the other and the outcome is just x, that means they've undone one another and they are inverses. Here is an example on this part A. F of x is -7x plus 2, and h of x is -1/2 to the x, -1/2 x. F of h of x means I put the h function inside the f function, which is taking -7 times the input, -1/2 x, and then adding 2. When I crank that out, that's 7/2 x plus 2. That's not equal to x. That's what we wanted. These are not inverses. Let's double check and just go the other direction. What's h of f of x? And double check that. F of x is, the h function takes -1/2 times whatever the input is, -7x plus 2. I'll need to distribute that -1/2, so that is 7/2 x minus 1. F and h are not inverses. If they were, we would have had everything equals x. That would have been the output. Let's try a second one here. F of x is x minus 9 over 2, and g of x is 2x plus 9. So see, like, look ahead here, and if one function takes away 9, then divides by 2, the other function in reverse doubles it and adds 9, those are going to be functions. But let's just, to confirm, take f of g of x, or g of f of x, or both. Let's say f of g of x means the g function goes inside the f function. 2x plus 9, then I take away 9, all divided by 2. That becomes 2x over 2, or x. Aha! Similarly, g of f of x means the f function goes into the g function, and the g function doubles whatever the input is. There I am doubling it, and then adding 9. That means, that's nice, that's x minus 9 plus 9 equals x. So these are inverses. These functions are inverses. Okay, objective 1 achieved. How to determine if two functions are inverses. Second thing is how to find an inverse. So the goal in this is to determine, we have got, let's see, find f inverse. Here's a nice, quick, easy way to determine the inverse of a function. Instead of these dots here, I'm going to place them into number form. There are 4 steps here. And our function in this example, this is j, f of x equals 2x plus 4. Number 1, replace f of x with y. It's a little bit easier, it's less things to write. They mean the same thing as an input and output, and we will stick with that convention. Y now equals 2x plus 4. That's a line, a linear equation. Number 2, switch x and y. So now instead of wherever there's an x, I'll put a y, and whenever there's a y, I put an x. I just switch them. So now instead of y equals 2x plus 4, I have x equals 2y plus 4. I've just reversed them. Step 3, solve the equation for the new y. That means this thing here that's now nestled next to the 2 and the plus 4, I need to unwrap. Unwrap algebraically, that means from the I'll need to subtract 4. That means x minus 4 equals 2y. And then I'll put a comma to show that now I'm going to divide by 2. X minus 4 over 2 equals y. I've solved for y. Now I can replace it with f inverse of x. So the inverse of something that doubles the input and adds 4 is to take away 4 and divide by 2. That's the inverse. Now, I will let you work on confirming that by putting in a composition of functions both ways to algebraically confirm that one is the inverse of another. I'll set you up. You should get equals x for both of them. So you found that how to find the inverse on this. I would suggest you hover over a couple of these and try to do them. I'm going to put answers here just to double check. Some of them, like this number 2, it's almost, you can tell what the inverse is going to be. The function here is x plus 5. It adds 5. It makes sense that the inverse is going to take 5 away. But others, it may be a little bit more difficult to see what they're going to be. All right, for number 4, we want g inverse. equals the fifth root, x minus 2 over 2. And then number 5 equals, this can be expanded. Number 6 is negative 2 over x plus 2, all minus 1. Okay, gonna let you, like, if you want to double check, you can pause and just see those answers there, and that should get you started. All right, thanks for